Hey everybody, here we have a polynomial equation that is just waiting to be solved. So let's buckle down. So the first thing we're going to do is we are going to, of course, always recognize what kind of equation we're looking at. And yes, we're looking at a polynomial equation. When solving a polynomial equation, you want to get everything on one side, you want 0 on one of the sides, and anything that you move from one side to another, you need to use the inverse operation to get it there. Also, I like to move everything to the side that will enable you to have a positive leading coefficient or leading term. So the leading term will be the one with the biggest exponent. The biggest exponent I see on the screen right now, or on the problem right now, is 3. On the left, I see 4x to the third, so I see a leading coefficient of positive 4, and on the right, I see 1x to the third. So I would want to take the 1x to the third from the right to the left with subtraction. That means everything's moving to the left, okay? So let's get into this example. So I'm trying to decide which way I want to write everything out, but I guess I will just start. I'm going to kind of take up some space. Yeah, I'm going to write underneath this. So I'm going to subtract x to the third. All right, let's focus that. There you go. I'm going to add the 3x to the second. I'm going to subtract 2x. I'm going to subtract 8. So on the right side here, gone, 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 gone. But everything I do on that side, I'm also going to do on the left. So if I subtract 1, I can't really write over there, sorry, the camera doesn't go there, 4x cubed minus x cubed, that's going to be 3x cubed. Then I have 2x squared, and I'm adding 3x squared because I'm doing it to both sides. Sorry, I didn't write it there. So 2x squared plus 3x squared is going to be 5x squared. Now this minus 2x I will duplicate right here. Whatever you do to one side, you do to the other. So minus 2x. Negative 10 and negative 2 means I have negative 12x. And then minus 8 on the left, so minus 8 on the right, so minus 8 on the left. So right there, I'm going to combine negative 12 and negative 8, and that gives me negative 20. Now on the right, gone, 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 well, what does that leave you with? When you're dealing with adding and subtracting and everything's gone, 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 that leaves you with 0. Now we're going to analyze what it is that we're left with. We don't have any other like terms left to combine. 3, 2, 1, none for my powers. This is a cubic polynomial of 4 terms. Whenever you have a polynomial equation, and especially if it's like a non-graphing calculator kind of assessment, if you're being asked to solve it, there's probably a 90% chance or greater that you would solve such an example like this one, third power, by factoring. If it were quadratic and factoring doesn't work, your other option is quadratic formula. And if you learned rational root theorem and factoring doesn't work on something like this, you would use that. We're in our curriculum right now, what this is being recorded for today, we have not gotten to rational root theorem. We're not going to apply that. So factoring will work, and we didn't get to the graphing approach or graphing calculator approach. So factoring will, I promise you, work. So the type of factoring I would do on something like this. Obviously, I would first check for a greatest common factor, but there is none. But now you're going to factor by grouping. Do not forget fundamentals. It always comes down to the fundamentals, okay? So what is the greatest common factor here? Slow down. Don't try to rush and do anything silly. It's going to be x to the second power. What's the greatest common factor out of these two? Now, some of you are going to say it's 2 or negative 2, and that's not right. It's not negative 2. So what do you do in the cases where the numbers are kind of difficult? Well, I'm glad you asked. So say I can handle this one. I'm confident x squared is my GCF. If I reduce over here, I have 3x. If I reduce over here, I have plus 5. X squared over x squared is not x. X's are gone. That's gone. Now, I'm going to, if this is a negative, if your leading term of the group is negative, you're going to pull something negative out. I don't know what that is yet. Parentheses equals 0. But I should, if factoring by grouping works, I should be left with a 3x plus 5 inside. So what you want to say to yourself is, well, negative 12 divided by what is going to be positive 3. Well, definitely divide by something negative. Negative what? Oh, negative 4. What about negative 20 divided by negative 4? Is that 5? Sure is. Look how smart we are. Amazing. Okay. Now, at this point, what is your greatest, much greatest common factor? Well, we have twinsies right there. 3x plus 5. So we're going to factor the 3x plus 5 all the way out front. So what does that look like? Well, let's just move this down. There we go. So if I pull that out front and out front, so one of them comes out front, you're undistributing, okay? What's left is 3x plus 5 out front, factored out. So that's pulled out front, undistributed. And what is going to be left inside is the x squared minus 4. And remember, it's an equation, it's equal to 0, so you don't want to ever lose the equation characteristic. But, let's scooch around, get ourselves some more room. There we are. Where are we going from here? I'll rewrite this step. So we have 3x plus 5, and we have x squared. Take away 4 equals 0. If the power is 1 when it comes to factoring, you're probably done. Biggest thing you could take out is maybe a constant as a GCF. 3 and 5 have nothing in common. They're both prime, so good the way it is. What about this cutie patootie? Well, if you said difference of 2 squares, you are also a cutie patootie in the math world. Good job. So how do I factor x squared minus 4? You might think to yourself, here's your thought bubble coming out of your head. Okay, and this is you thinking, okay? So you might be thinking to yourself, self, what's being squared to make x squared? X. What's being squared to make 4? 2. X and 2 are going to be the ingredients we're going to deal with for this particular situation. So we'll have conjugates, x plus 2 and x minus 2. Beautiful. Equals 0. Now, when the power on x is 1, you're probably done when it comes to factoring. So now what we do is we apply what we call the zero product property. We have 3 different factors, so we're going to set each piece of this giant product, each factor, equal to 0 and solve for x in each case, and we'll get 3 different answers. Usually, the largest exponent in a problem is a big clue as to how many different answers you might be getting. So here we go, 3x plus 5 equals 0. Subtract 5 from both sides. 3x is equal to negative 5, and then divide both sides by 3. X equals negative 5 over 3. There's one answer right there. Next, x plus 2 is equal to 0. Subtract 2 from each side. That's gone. X equals negative 2. There we have another beautiful answer. And last, and surely not least, can I fit it? Let's see. X, take away 2 equals 0. Am I on the screen? Add 2 to both sides. Go down here. X equals 2. And there's your third answer. Isn't that lovely? So if you are happy and you know it, clap your hands. If you're smart and you know it, thumbs up. If you didn't like this breakdown explanation, give me a thumbs. What did I say? Thumbs up or thumbs down before? Thumbs up if you're happy and smart, feel good. Thumbs down if you hate it. And hope this was helpful. Click through for the next example. Adios.